Okay, so we're going to look at theoretical and experimental probability. So we're going to find the theoretical probability of an event happening, which theoretical means what we expect. And then we're going to look at finding experimental probability of an event, which means is what we get when we actually do an experiment and the results that we get. So first of all, probability is a measure of how likely an event is to occur. The result of an experiment is an outcome. All of the possible outcomes you could have is called the sample space. And an event is an outcome or set of outcomes. So here we have two different situations. One is, they're playing Battleship. You guys ever play Battleship? Okay, that's a good game. Right. So an experiment could be like rolling a number cube. If you roll a number cube, you could have the numbers 1, 2, 3, 4, 5, and 6. So those would be the sample space. Or you could spin a spinner like this one and get the results of red, blue, green, or yellow, and each one would have a probability of 1/4, right? Okay. So probabilities are written as fractions or decimals between 0 and 1, or as percents between 0 and 100%. So if you have 0%, it's impossible for something to happen. If you have 100%, it's going to be, certainly it's going to happen. And if you have 50%, it's as likely to happen or not. So there's a lot of vocabulary with this stuff, okay? Equally likely outcomes mean they're all the same. So with rolling a number cube, getting numbers 1 through 6, they are all equally likely because they're all 1/6 the probability. Spinning the spinner here, as long as all 4 parts are divided evenly, then they're all equally likely of getting red, blue, green, or yellow. Okay. Favorable outcomes are the ones that we're trying to get. And for equally likely outcomes, the theoretical probability event is the ratio of number of favorable outcomes to the total number of outcomes. So this is a formula we're going to be using a lot in the next couple days. Finding the theoretical probability. We'll be using it for experimental probability also. The probability that an event happens, when I have P parenthesis like that, means the probability of that thing happening, is the number of favorable outcomes divided by the number of outcomes in the sample space, or the total possible. So for instance, if I was going to spin the spinner, okay, and I wanted to get red, okay, how many favorable outcomes would there be? How many red areas are there? There's one red area, right? Okay, and how many areas are there altogether? 4. So the number of favorable outcomes would be 1 because there's one red space. The number of outcomes in the sample space would be 4 because there's 4 different options there. Okay? Or if it was rolling a number cube, if I wanted to get a 5, okay, there's 1 favorable and 6 total. So we're always finding probabilities. In the numerator is going to be our favorable outcomes, what we're trying to get. In the denominator then will be how many possible outcomes there are, the total. Okay. So here we have the word probable. All the letters are put on a separate note card. The cards are placed face down, mixed up. What is the probability that a randomly selected card has a consonant? So we want to find the probability of a consonant. So in the numerator, we'll have the favorable outcomes. And in the denominator, we'll have the total outcomes. Okay. So favorable in this case would be what? okay, or a consonant, right? Okay, so there are 1, 2, 3, 4, 5 consonants. So there are 5 favorable outcomes. Okay, and how many outcomes are possible? So how many cards would there be? 8, because there's 8 letters. And so the probability of getting a consonant would be 5/8. So there are 5 consonants out of 8 cards. Okay. Letter B. And we're going to see this chart we're going to see quite often. I need to put that somewhere. Okay, so 2 number cubes are rolled. What is the probability that the difference between the 2 numbers is 4? Okay. So we want the favorable outcomes in the numerator and the total possible in the denominator. So let's look at the total first of all. How many total possible outcomes are there? How many different pairs are there? There's 36 of them, right? Because we have the numbers 1 through 6 in red and 1 through 6 in blue. So there are 36 total outcomes. So how many of them show that the difference between the 2 numbers is 4? So that would be what? Which ones are show those? Okay, 5 and 1. All right, so let's see. Here's a 5 and a 1 here. And there's a 5 and a 1 there. And what else? 6 and 2. So here and here. Okay. So how many favorable outcomes are there then? 4. So I have 4 out of 30. So we have 4 out of 36 or 1/9. Now the sum of all probabilities in the sample space is 1. So when you add them all up, it's got to equal 100%. The complement of an event is a set of all outcomes that are not in that event. In other words, I could, for our class here, I could say, what's the probability of not getting a girl? Okay, and that would be 1 out of 6, because there's one person that's not a girl. But I could say 1 minus 5/6 to find that answer. So the complement is basically just saying that we take what we know and subtract that from 1, and we can find the answer we're looking for. Okay? Or I could say how many chairs in this room don't have a student sitting in it. Okay? So if I had 30 chairs, then there are 6 out of 30 that have students in them, so I could do 1 minus 6 out of 30 to get my probability. Now, a lot of times you can find the answer without necessarily using the complement also. So for instance, in this question, it says there are 25 students in study hall. Anybody know what study hall is? Yeah, it's kind of like forum. Yep. The table shows the number of students who are studying a foreign language. What is the probability that a randomly selected student is not studying a foreign language? So we can answer this question 2 ways. We can answer it by using the complement, or we can answer it just by subtracting the numbers that we know. So if there's 25 students in a study hall, all right, so I'm looking for my favorable outcomes in the numerator and the total in the denominator. Okay, so my total is there's 25 students altogether. And 25 minus 18 and 3 is 21 would be how many are not studying a foreign language, right? There's 21 studying a foreign language, and so 4 out of 25 would be the number of students that are, or the probability a student is not studying a foreign language. And so that would be the same as if we did the complement, which would be doing 1 minus 21 out of 25, which would still give us 4 out of 25. So you can think of it the first way we did, okay, just by subtracting, okay, or you can do it using the complement. Either way is going to get you a satisfactory answer. Okay, finding probability with using permutations or combinations. Each student receives a 5-digit locker combination. What is the probability of receiving a combination with all odd digits? Now, this question always makes me curious because they talk about using permutations and combinations. And in reality, we can do this problem without. Okay? So let's think about all of our work with digits the other day. Okay? But we're still going to work with number of favorable outcomes and the total number of outcomes. So we have our favorable in the numerator. And the total in the denominator. So let's think about total first of all. How many total different locker combinations are there that have 5 digits? Well, let's see. How many choices are there for the first digit? 10. How many for the second digit? Third digit, fourth digit, and the fifth digit. So this is 10 to the fifth power, right? Because there are 10 times 10 times 10 times 10 times 10 choices for all locker combinations. Okay, so the total then is all the possible locker combinations there could be. The favorable then is how many of them have all odd digits. Okay, so what's the probability that the first number, or how many odd digits are there? There's 5 of them. And if they're all odd, then that means that there's 5 for the first one, 5 for the second, 5 for the third, 5 for the fourth, 5 for the fifth. Okay, so 5 to the fifth power. So this is going to be 5 to the fifth power over 10 to the fifth power. So 3,100 3,125 over 10,000. Or is that 100,000? 100,000. So it's still, we're just looking at numerators, favorable outcomes, denominators, the total number of outcomes. Okay? We have a 5-digit locker combination, could have 10 to the fifth power different combinations, and the ones that have just the odd digits in, there are only 5 possible for each one. So let's look at this one together here. That was it. Yeah. All right, so here a DJ randomly selects 2 of 8 ads to play before her show. 2 of the ads are by a local retailer. What is the probability that she will play both of the retailer's ads before her show? give you a moment to think about it. Okay, so let's talk about the total outcomes first of all. Okay. How do we find that number? A combination of what? Okay, combination of 8 choose 2. That's right, because the DJ randomly selects 2 of 8 adds. So there's no order to those adds. Okay, so it's a combination of 8 choose 2. Says 2 of the ads are by the local retailer. What's the probability that she will play both of the retailer's ads before her show? So what's the favorable outcomes then? Okay. How many ads is she going to choose to play? 2. And how many does that local retailer have? 2. Is there any order to how she picks those 2? No. So the numerator is going to be a combination also, but it's going to be a combination of 2 choose 2. Now I want you to think about it, the numerator for just a second, okay? How many different ways can I choose 2 from 2? There's only one way, right? There's only one way to choose 2 from 2, so that's why a combination of 2 choose 2 or 5 choose 5 or 8 choose 8 is always going to be 1, because there's only one way that can happen, and a combination of 8 choose 2 is what? 28. So the probability that she will play both of that retailer's ads before her show are 1 out of 28.